Hi everyone. In this video, I am going to discuss on permutation and combination problems in which distribution of things are involved. I have incorporated different varieties with shortcut in such a way that you will be able to answer such questions within seconds. The distribution problem, we can divide it into two types. The one in which identical objects are involved and other in which the objects are distinct. Again, in identical, there are questions in which no restrictions is given. Also, in some questions, there is no empty group involved. That means the possibility of zero is not considered. In distinct case also, we will get questions with no restriction involved as well as there will be questions with some conditions involved. Now we will look into different examples. We'll start with distinct type. So for distinct type we have a shortcut like number of ways in which n distinct things can be distributed to r different persons is given by r power n. Example 1. Find the number of ways in which 7 distinct books can be distributed among 5 children. So here r is 5 and n is 7. So how we will approach this problem? Here book 1 can be given to child 1, child 2, child 3, child 4 or child 5. So book 1 can be distributed in 5 ways. Similarly, book 2 can be distributed in 5 ways. Likewise, book 7 can be distributed in 5 ways. So number of ways the book can be distributed is 5 into 5 into 5 into 5 into 5 into 5, that is 5 power 7 ways. In the previous question, we have seen how to distribute n different things to r different people, which was given by r power n, right? But there we have considered the case of giving the entire n things to one single person. Now, what if in the question it is asked in a different way? So there we have number of ways in which n distinct things can be distributed to r different person such that not all is given to one. And it's given by r power n minus r. Example 2. Find the number of ways in which 8 distinct toys can be distributed among 6 children so that every person receive at most 7 toys. So here, in the question it is given that every person receives at most 7 toys. That means not a child is receiving entire set of 8 toys. So we'll begin with toy 1 can be distributed in 6 ways. Toy 2 can be distributed in 6 ways. Similarly, toy 8 can be distributed in 6 ways. Now, from this we have to subtract the possibility of child 1 receiving the entire set of toys, child 2 receiving the entire set of toys, likewise, right? So from the total we have to subtract 6 possibilities. So number of ways is 6 power 8 minus 6. The last two examples dealt with problems involving distinct objects. Now we'll see how to approach problems when the things are identical. And we have number of ways in which n identical things can be distributed to r different persons when each person may get any number of things, meaning the person may get things varying from 0 to n, and is given by n plus r minus 1 c r minus 1. Example 3. Find the number of ways in which 15 apples can be distributed among 5 persons. So here N is 15 and R is 5. So substituting in the equation, we get 19C4. That means 15 plus 5 minus 1. 19C 5 minus 1, 4. So that is our answer. The previous problem, logically we can approach in a different way. The question was the number of ways in which 15 apples can be distributed among 5 persons. So distributing 15 apples among 5 persons. That means we have to make apples in 5 sets. In order to make 5 sets, we have to make 4 partitions. That means 4 partitions will give you 5 sets, right? And these partitions I can make in different way. I can do like this. This is one partition. So any way I can do this. Now this is like number of ways of selecting 4 lines, right? That means out of 15 plus 4 things you have to select 4 lines, and this can be done in 19C 4 ways. That is from 15 apples and 4 lines. That means in total 19 things you have selecting 4 things. The last example included the possibility of a person getting 0 apples also. Now what if it is not needed? Then the number of ways in which n identical things can be distributed to r different person excluding empty possibility is given by n minus 1 c r minus 1. Example 4. Find the number of ways of distribution of 8 identical balls in 3 distinct boxes so that none of the boxes is empty. So here n is 8 and r is 3. So our answer would be n minus 1 c r minus 1, that is 8 minus c, 3 minus 1, that is 7c, 2. Example 5. How many solutions are there to the equation a plus b plus c equal 100? Given that case 1, a, b and c are whole numbers, case 2, a, b and c are natural numbers. Now, you might wonder that how this question is related to permutation and combination. Actually, this is like distributing 100 chocolates among 3 children. And case 1 is considering the 0 possibility also. That means possibility of a child getting 0 chocolates also. And case 2 is not considering the possibility of getting 0 chocolates. So for case 1, the number of solutions would be n plus r minus 1 c r minus 1, that is 1 or 2 c 2. And for case 2, that means not considering the possibility of getting 0 chocolate to a child. And it would be given by n minus 1 c r minus 1, and the answer is 99 c 2 ways.